Solar panels produce electricity, but what is electricity and what are the basics you should know before designing a PV system? Understanding the basics is also important when it comes to talk to curious customers. In this lecture, I will present concepts and discuss how they interrelate each other. Electrical energy supposes the flow of electrons within a conductor. Energy can be understood as the capacity of doing a work. Electrical energy is not created. It comes from the conversion of other energies. A generator, for example, converts mechanical energy into electrical energy. A battery converts chemical energy into electrical energy. Electrical energy is measured in kilowatt hours. It is the product of power expressed in kilowatt and time expressed in hours. Therefore, electrical energy is power over time. In our everyday life, kilowatt hours is what we pay power companies for. Electric power in watt is obtained by multiplying voltage expressed in volts and current expressed in amps, and power is defined as the rate at which energy is supplied to a circuit or a load. It is energy over an instant. Power, energy over an instant. Energy, power over time. But what is voltage and what is current? Electricity is the flow of electrons, and the current, the amount of electrons passing in a single point of a circuit. Making an analogy with the water hose, current can be compared with the quantity of water and voltage with the force or pressure that is necessary to move water. Just like in a water hose, if we increase the voltage or the pressure, then the current or the water flow will increase. Resistance refers to the resistance to the flow of electricity through a conductor. It is measured in ohm. Resistance reduces the voltage. Referring again to a water hose, an increase in the pressure causes the flow to increase, but getting a kink in the hose, increasing the resistance, will cause the flow to decrease. Voltage drop in a circuit is calculated by multiplying current and resistance. The relationship between voltage, current, and resistance is described by Ohm's law. Together, a power source, conductors, and loads make an electric circuit. Electric circuit can be configured in series or in parallel to power several loads such as light bulbs, TVs, washing machine, and many others. In a series circuit made of load 1 and load 2, the negative of the load 1 is connected to the positive of the load 2. Current is constant in series circuit and voltage adds. In parallel circuit, the negative of the load 1 and 2 are connected together, and the positive separate from the negatives are also connected together. In a parallel circuit, current adds and voltage remains constant. Solar panels are DC sources. DC referring to direct current. In DC electrical systems, the charge carrier's flow or movement stays the same at all times. Alternating current or AC refers to electrical systems where the electric charge carriers periodically reverse their moving direction. Generators, for example, are AC sources